Hello, the thumbnail for this video explained that we are going to cover 9 trigonometric identities with 3 easy concepts. Now, the first concept is periodic. All of these functions, sine function, cos function, and tangent function, have a particular period, which means it repeats over time continuously in one way. So for the sine function, we start at 0, we go through pi radians, 2 pi radians, and this means from here to here, the period is 2 pi. 2 pi across there. And it just repeats forever in both directions. The cos function is the same. From here to here, we have a period of 2 pi. 2 pi. And for the tangent function, between these asymptotes is a period of pi. Just 1 pi for tangent. So these facts tell us that the sine of theta plus 2 pi is equal to the sine of theta, and in the same way the cos of theta plus 2 pi is equal to the cos of theta, and again for tangent, the tan of pi plus theta is equal to the tangent of theta, because wherever you go, say we have an angle here, this angle is the same as this angle across here, which is a difference of pi radians, and it will repeat the same over here, and if we go in this direction, it's the same forever and ever and ever. So this is the identity. Okay, so let's do a practice question for each one of these identities to illustrate how we understand it. So let's say we have the sine of 7 pi over 3. This identity tells us that the sine of 7 pi over 3 is equal to the sine of pi over 3 plus 2 pi, because 2 pi is 6 pi over 3 plus pi over 3 is 7 pi over 3. So all we need to know is the sine of pi over 3. This is our angle, this is our angle here, which is equal to root 3 over 2. Okay, now let's do cosine. Let's say we have cosine of 17 pi over 4. Now this is equal to the cosine of pi over 4 plus the cosine of 4 pi. Well, now this is interesting because our identity says the cosine of theta plus 2 pi is equal to the cosine of theta. But considering that this function is periodic and it has a period of 2 pi, any multiple of 2 pi is going to give us the same answer. So for all of these identities, we could say we have n here, where n is any integer. So our answer for this is simply the cosine of pi over 4, which is 1/2. Okay. Now let's look at our final one, tangent. Let's say we have tan of pi over 3. Now this is equal to the tan of pi minus the tan of 2 pi over 3. Now we have a minus sign here. This is fine because these functions are periodic. They repeat forever in both directions. So for all of these identities, we could have a plus or minus here. Plus or minus, plus or minus, plus or minus. So really, we know what this is anyway. Tan of pi over 3 is equal to root 3. So this elucidates these three identities for us. We have plus or minus just because we can, but we keep them simple, so say theta plus 2 pi, theta plus 2 pi, or pi plus theta. Now for our next three identities, we're going to consider the symmetry of these graphs, mirror symmetry in particular. If we consider an angle on the sine graph, let's say here, it's not a very well constructed graph, but if we have, say, sine of pi over 2, this is pi over 2 here. If we look at this, we can see that the angle of pi over 2 here, if we mirror this across using the vertical axis, then we will have negative pi over 2 here. And there is a relationship here. This is equal to 1, and this is equal to negative 1. So this tells us that the sine of negative theta is equal to the negative of sine theta. So whichever angle we have along here, then it's going to be the negative opposite this axis. Moving on to the cosine, this vertical axis is a perfect line of symmetry. If you swap these sides over, everything is the same. So this one is very easy to understand. The cosine of negative theta is equal to cosine of theta. Very nice. For the tangent function, this is very similar to the sine function. You see, we have a period of pi here between the asymptotes, and it's the same as the sine function in that the identity for any angle tan of negative theta is equal to the negative of tan theta. So if you have an angle here, let's say pi over 3 for example, then opposite the vertical axis you have this angle's value on the y-axis, then it will be the negative of that angle. So the symmetry runs across the x and the y. So let's do some examples for these. Let's say we have sine of negative pi over 3. Now this is equal to the negative of sine pi over 3, which is equal to negative, the sine of pi over 3 is root 3 over 2. So our angle was about here. That's negative 3 over 2. So with the cosine, let's say cosine of negative pi over 3 is equal to cosine of pi over 3, which is equal to 1/2. This one was very simple because negative pi over 3 is about here or so, and pi over 3 is over here. So these are equal values. And now let's do the tan of negative pi over 3, which we know is equal to the negative of tan pi over 3. which is equal to negative root 3. Okay, our final three identities here are the reciprocals of these functions. The reciprocal of the sine function is cosecant of theta, and for the cosine function our reciprocal is secant theta, and for the tangent function our reciprocal is the cotangent of theta. Now this is equal to 1 over sine theta, this is equal to 1 over cos theta, and this is equal to 1 over tan theta. These are only true provided sine theta is not equal to 0, sine theta is not equal to 0, cos of theta is not equal to 0, and tan of theta is not equal to 0. So we have to be careful that we're not dividing through by 0, because that's meaningless. Today you have a bonus identity. The tan of theta is equal to the sine of theta over cos theta. Sine theta over cos theta. So the reciprocal of the tan function, cot theta, cot theta is equal to cos theta over sine theta. The end of today's video. If you enjoyed it, click on the subscribe button, comment, like and share. See you next time.